Welcome to the second video on sum and difference formulas, and today we're going to be focusing on just the tangent function. And again, I would like you just to accept the formulas the way they are. I might prove them to you after Unit 6, but just for now we're focusing on can you use them correctly. And just like the sine and cosine video, the point of them is if you're given an angle that's not on the unit circle, you can use angles on the unit circle and write them as a sum or a difference. Now, also something relating back to the other video that I want to point out to you. As you know, tangent of an angle is equal to sine of an angle over the cosine of an angle. And if you're given tangent of a sum, notice that the top really represents sine, and sine is a y value, and this would be cosine, so this is really an x value. The y values in transformations do exactly what you want, so the sine stays the same. However, the x value, or the cosine, does the opposite, so the sign changes. Same thing happens for this example. You're given the tangent of a difference. Notice the sign stays the same on the top, but it changes in the denominator because x always does the opposite of what you want it to. So even though you may not necessarily have to memorize these formulas, this is a good gut instinct for you, so you're not using a ton of time on a test to remember the signs. These little tricks might help you speed up your testing process. So let's get to using it. Again, I have the unit circle given to you in degrees to start. So I have this idea, and I'm given tangent minus tangent on the top and 1 plus tangent on the bottom. Again, I want you to get to the point that if you see something like this, you recognize that it is a sum or difference formula. And the sign on the top is a subtraction, so if we go back here, remember that the sign stays the same on the top. So this is really tangent of A minus B. So in this case, the two angles are 165 and 45. So instead of this mess, we're rewriting it as a single trig function, and if I reduce that, that would be tangent of 120 degrees. Now the tangent of 120 degrees, again just as a reminder, the tangent of any 30-based angle is root 3 over 3, the tangent of 45-degree angles is 1, and the tangent of any 60-degree based angle is at root 3. So we're dealing with this position. It means I have a root 3 here, but tangent is negative in this quadrant. So my answer is really negative root 3, because that is the tangent value at that angle. If I look at number 2, it's the opposite of number 1. Notice that the sign on the top is plus. If we go back, when the sign on the top is plus, it comes from tangent of a sum. And it is the exact format that we need. A sum on the top and the subtraction on the bottom. So this time, I can use tangent of A plus B, which would be tangent of 7 pi over 12 plus 2 pi over 3. Now, again, I definitely need a common denominator here. The common denominator is going to be 12, so I'm going to multiply this by 4 over 4, and I would get tangent of 7 pi over 12 plus 8 pi over 12, which would get me tangent of 15 pi over 12, which reduces to tangent, if I divide both by 3, 5 pi over 4. If we look back at the unit circle given with radians instead, so I'll bring that over here. Sorry about that. Bring that over here. The tangent value at 5 pi over 4 is right here. So that is a pi over 4 based angle of 45, so it has to be some sort of 1. Because it's in the third quadrant, the tangent is positive, so this answer is actually just positive 1. So again, like the last video, one process we need to understand is going from a more complicated to condensing it to something that we recognize and then using the unit circle to find an exact answer. Okay, so now let's work the other direction, and we're given the tangent of 195, which is not on the unit circle, and we're going to try to find an addition or subtraction fact to rewrite this. So let me think. We could do the tangent of 150 degrees plus 45 degrees. We could do the tangent of 135 degrees, which is on the unit circle, plus 60 degrees. We could do something with subtraction, the tangent of 225 degrees minus 30 degrees, and I'm sure there's even more that we could use. Now, from teaching this before, here's a suggestion for you. You might notice that over here, when we expand, we could have a fraction over a fraction, which means if I plug in a tangent value that's also a fraction, we'd have to get a common denominator on the top and then divide. So if you quickly recall again that the tangent values are root 3 over 3, 1, and root 3, my suggestion would be avoiding any 30-based angle. So 30, 150, 210, or 330. The reason being, if you have to plug root 3 over 3 in for a tangent value, again, you're going to have a fraction plus another fraction, get a common denominator, and it's just going to be an absolute mess. So I would suggest avoiding any 30-based angle. So I'm going to write that. Avoid 30-degree based angles in terms of position. So I am going to avoid this first example, and I'm going to avoid this last example. So I'm going to use this guy, tangent of 135 plus 60. And if I'm dealing with plus, I'm dealing with the tangent of a sum. So I'm going to rewrite it like this. Tangent of my first angle, 135, plus the tangent of my second angle, which is 60 degrees, over 1 minus the tangent of 135 times the tangent of 60. So let's see what we know. The tangent of 135 degrees is going to be -1. So this is replaced with -1 plus the tangent of 60 degrees is root 3 over 1 minus tangent of 135 we already found as -1. Tangent of 60 is still root 3. So this becomes -1 plus root 3 over 1 plus root 3, because the negative times negative. Now, if you did not want your answer rationalized, and if your teacher says that's okay, you can leave your answer like this. But, as a lot of you know, we can't have a radical in the denominator. So what we could do is multiply top and bottom by the conjugate. So we could multiply by 1 minus root 3, 1 minus root 3, and we can simplify. If I multiply on the top, I would get -1 plus root 3 plus another root 3 minus root 3 times root 3 is really 3 over, so let's FOIL again, 1 times 1 is 1, 1 times root 3 is negative root 3, root 3 times 1 is positive root 3, root 3 times negative root 3 is -3. Now, if you multiply by the conjugate, it's always going to be the case that these two middle terms cross out in the denominator. That's what you want. That's what the conjugate does. Now, in the numerator, I have -1 combined with -3, which is -4. Root 3 plus itself is 2 of them. In my denominator, if these cross out, I get 1 minus 3, or -2. Now, just like the quadratic formula, where we can reduce this triangle of numbers, let's divide everything by 2, or the GCF. So I would get -2 plus 1 root 3 all over -1. And if you would like to even reduce that further, you're technically dividing everything by -1. So this becomes a +2 and a negative root 3. So all of that reduced to just 2 minus root 3. So let's do one more example. In terms of try on your own, I would like you, just like the last video, to pause it and see if you can come up with any angles that together add to be 165 or subtract to be 165. So please pause now. Okay, here's a few examples I came up with. If you found another example that I didn't, please feel free to tell me in class the next day. Again, I would highly suggest avoiding all angles that are 30 based, because the tangent value is root 3 over 3. And as you can clearly tell from the last example, if we have to get a conjugate, that is going to be such a pain. So I'm going to cross out this example. I am going to cross out this example. So if I'm between these two, because, again, either of them would work, but because the last time I ended up choosing the tangent of a sum, this time I'm going to choose the tangent of a difference for the video purpose. But you can try this one too and see if you get the same answer. So if I'm doing tangent of a difference, I am going to take this and make it into this, or expand it. Tangent of 300 degrees minus tangent of 135 degrees over 1 plus tangent of 300 degrees times the tangent of 135 degrees. So the tangent of 300, again, this is really a root 3 over here. Tangent in the fourth quadrant is negative. So this is really negative root 3 minus tangent of 135. Tangent is also negative in this quadrant. This is 45 degree based, so that value is negative 1. So it's minus a negative 1 on the top. In the denominator, it is 1 plus tangent of 300, we already said was negative root 3, and tangent of 135 was negative 1. So if we simplify this, it's going to be negative root 3 plus 1 in the numerator, and the denominator is going to be 1 plus root 3 because of the negative times negative. Just like last time, because I know I should not have a radical in the denominator, I'm going to multiply by the conjugate of the denominator, because that's where I can't have my radical. So if I multiply that out, I would get negative root 3 minus, or no, plus 3, because negative times negative is positive, plus 1 minus root 3 in the numerator. In the denominator, just to save a step, I know I'm not going to have a middle term. It's going to cross out, but that's what a conjugate does. So I'm just going to have my first terms and then my last terms, so minus 3. So this numerator, I would get 3 plus 1, positive 4, negative 3 minus another root 3, that would be negative 2 root 3 over negative 2. Again, this should remind you of the last example because you're picking similar values. If you do the triangle of numbers, we can again divide by 2, and we would get that to be 2 minus 1 root 3 all over negative 1. Or even better, if you divide everything by negative 1, you would get negative 2 plus root 3. You could also write that answer as root 3 minus 2. Kind of like the previous one, we could have written that final answer as negative root 3 plus 2 if we'd like as well. All right, I know that this is a tedious process, but again, thanks in advance for practicing. The more you do it, the better you'll get. Thank you.